So there'll be an exam next Friday. This Friday we'll have a group assignment. Any questions? Uh, So for those who just came in, next Friday, not this Friday, there will be an exam. And just like the last one, there'll be a review, and there'll be a take-home portion and an in-class portion. And the take-home portion would be due a week from this Sunday. So, any questions? Okay, let's try. We were in section 6.3. I want to do a story problem. Because it kind of uses information from the last chapter, because you need to find the vertex. So it says the price in thousands of dollars from producing X units. Of an item is P equals, and it's a lower P when they're talking about price. Profit is usually P of X, and it's a capital P. But when it's a lowercase p, it's price. $10 minus 0.002x. First thing, find the revenue function. To find the revenue function, revenue is price times quantity. And our price is 10 minus 0.002x. Our quantity, in this case, is just x. In most cases, it's just x. But it's your price times your quantity. Distributing the x, we have 10x minus 2,000th x squared. So that would be your revenue function. And since this was in thousands of dollars, this would stay in thousands of dollars. Any questions on that? Find the average rate of change from 1,000 to 1,002 units. Well, when we're going between two values, remember that's the slope. And you could use the formula f of b minus f of a over b minus a. Now you could plug it in and do it, or you can plug it under y equals. For this. So I'd put my 10x minus 0.002x squared. Now you don't need to graph it. You just need to go to the table, second and table, and then I'm going to delete the two values that are there by hitting delete and plug in 1,002 and 1,000. We get so these would be your 2 points. So if you just wanted to use your slope, 8,012 minus 8,000 over 1,002 minus 1,000. Just your slope. So as we go from selling 1,000 units to selling 1,002 units, we increase our revenue by $6,000. Any questions on that? And what if we want to find the instantaneous rate of change at 1,000? So when it's between two values, you use your slope. But when it's at one value, and after this problem, we'll learn another way of finding it. But it's the limit as b approaches the 1,000, f of b minus f of 1,000 over b minus 1,000. Any questions so far? No questions? Well, we know f of 1,000. We already found it up here. It was 8,000. So we'll plug in the limit, excuse me, as b approaches 1,000. F of b, equation's right here, 10b minus 0.002b squared minus f of 1,000 was 8,000. All over b minus 1,000. Any questions so far? Now, if we put 1,000 in here, I think we should get 0. Yeah. If you plug it in, you get 0 over 0. Everyone getting 0 over 0? That means that this factor is also on the top. So we have to reduce it. Now, you could use your rules of factoring and trial and error, but we know that this factor has to be here. That's how you're getting 0 over 0. So if this has to be a b, this one, when I multiply the first two, needs to be 10b. So this has to be 10b, or just 10 actually, you don't need the b. That way when you multiply them, you get 10b. Wait, let me put these in order first. It's hard to try and factor it if you don't have them in decreasing order. So the negative 0.002b squared should be first. The 10b is the middle term, and then the 8,000. So if you're going to factor, you should put them in order first. That way you can look at the first term and the last term. Those are the only two you need to worry about when you're doing the trial and error. Because we know it has to have a b minus 1,000. So make sure they're in order first, because then your first two terms, when you multiply, have to add multiply to this one, and your last two multiply to this one. We have a b, we need negative 0.002b, so that when I multiply those two, I get the first term. Then the 1,000 times this value has to get us a negative 8,000. Well, we already have a negative 1,000. I only need a positive 8, so that when I multiply, I get this. The middle term will work itself out. We know it will because we have 0 over 0. So I took this factor and used it on top because that gets the 0 over 0. And then I looked at b and said, what do I need to multiply by to get this? Well, I need to multiply by a negative 0.002b, because if I multiply these, I'll get that. Then I looked at my negative 1,000. what do I need to multiply this by to get the negative 8,000? Well, I need an 8. 8 times negative 1,000 is negative 8,000. Now, if you do the outside and the inside, you're going to get a 10b. Any questions on the factoring? So that's one way of doing it. You could use long division and divide this. You could use synthetic division. Any questions? Okay. These will cancel. And once this bottom one cancels, you can plug your 1,000 in again. Two, 10. No, that's a negative. So we get $6,000. If we are already selling 1,000 units, if we sell one more, we'll make an additional $6,000. So if we go one more, we'll sell an additional $6,000 in revenue, which means the last one, notice if we sold two more, we were still only making $6,000 in revenue. So selling that extra one, we're not making any extra money. It's probably at the top of your parabola coming down. So you're not making any money after the 1,001. Because the change from 1,000 to 1,002 was 6,000, and so was this one. So selling one more will get you the same as selling two more. There's more supplies that need to be purchased, and so then you lose money right there. So that's where the break in your line is, and that's things you're looking for. This one, if I sell one more, 1,001 unit will bring me $6,000. But this one said if we sell from 1,000 to 1,002, we make an additional 6,000. So that 1,002 unit, there must be a big cost there. Maybe a machine needs overhauled before you do that one, or more items need ordered for that one. And so there's a drop there. Any questions on that? Now, after your test, we'll learn a short version. Six 6.4 is the definition of the derivative. And it kind of reviews what we just did. at least for the slope part, but then there's another version, a 4-step process. But there's what's called the difference quotient. And the derivative. The difference quotient is the slope, f of b minus f of a over b minus a. The derivative is the limit as b approaches a of f of b minus f of a over b minus a. Those are the two problems we just looked at. Now in this section for the derivative, it shows a 4-step derivative. I'll give you the steps in a minute, but so there's 2 different ways of getting this. And then in the next chapter, we learn another way. Well, how do you know when to use which one? For this one, this is the slope of the secant line. It's average rate of change between 2 values, average cost, profit, revenue. So if you're looking for the average cost, profit, or revenue between 2 values, use the difference quotient or the slope. For the derivative, it's the slope of the tangent line. Instantaneous rate of change for revenue, profit, or cost. And a lot of times instead of instantaneous, they'll say marginal. So marginal cost, marginal revenue, and marginal profit. So if it says marginal or instantaneous, you have to use one of these 2, which I'll show you this one in a minute. And if it says average rate of change, slope of the secant line, so average means slope. Another thing you can tell is you're given 2 points here. Here for instantaneous and marginal, you're only given 1 value. Here you're given 2. Not sure if you'll be given lines. I'm not sure if there was any on there where you're finding the slope of the tangent line. When you're given the graph, you just count your slope. Looks like it goes here. Here's 1 point on this line, and here's 1. So it goes up 2 over 1. The slope is positive when it's going up. This would be negative going down. But this slope is down 1 and right 1, so it's negative 1 over 1. So you're just counting your rise over run. It's going from here and here. So we go up 1 and over 1, 2, 3, 4. So this would be 1/4. Up 1 and over 1, 2, 3, 4. And these are the tangent line because they're touching the graph at only one point. Any questions on that? This one, a horizontal line, remember slope is 0. A vertical, the slope is undefined. Also, notice this one where the slope is 0, the tangent line. Look, that's a low spot on the curve. So when you have your lows and your highs, the tangent line is 0, where you're increasing and decreasing change. And so if we find those, then we know where our highs and lows are. So it's another way of finding vertex, the high and low on a graph. Any questions? A 4-step process. Now, some of this you've already done before, and that's why I made you practice it in earlier sections. The first thing you do is find f of x plus h. Second thing, find and simplify f of x plus h minus f of x. Next, divide by h. And lastly, and the limit as h approaches 0 of f of x plus h minus f of x all over h. Now, some of these, depending on the number, the problem, if this doesn't simplify, then I do the whole step at once. But if it does simplify, then I don't do the whole step at once. Also, the symbol they use for derivative is f prime of x. So this symbol means the derivative. So let's find the derivative of this. So to find the derivative, let me put that over here. Using 4 steps. The first step, we find f of x plus h. That means wherever there's an x, put an x plus h. Now you want to multiply everything out, but is there any questions on that? So we need to square this. X squared plus 2xh plus h squared plus distributing the 9. 9x plus 9h plus the 2. Distribute the -4. -4x squared minus 8xh minus 4h squared plus 9x plus 9h plus 2. So this is f of x plus h. That's step 1. Now step 2, you want to take this, and you could squeeze it in here. I just didn't leave enough space. You want to take that answer and subtract the regular function. Step 2 was f of x plus h minus f of x. So we take our last answer, -4x squared minus 8xh minus 4h squared plus 9x plus 9h plus 2 minus the original function right here. -4x squared plus 9x plus 2. So this was the original. Any questions so far? That's why I made you do this problem. I think it was on the take-home part of the exam, I think. Now, instead of having to rewrite again, I'm going to distribute this negative. It changes these signs. So if I make this a plus, this becomes a plus, this one's a minus, and this one's a minus. Everything in that parenthesis needs to cancel. If it doesn't cancel, you did something wrong somewhere. Notice that positive 4x squared and a negative 4x squared, they cancel. This 9x is now negative, and it cancels with this negative, this positive one. One's positive, one's now negative. Same thing with the 2's, positive 2, negative 2. Anything that's left should have an h in it, or you did something wrong. So we have f of x plus h minus f of x equals -8xh minus 4h squared plus 9h. Notice they all have h's, 3 terms, all with h. Any questions on that part? So that's the end of step 2. Step 3, we divide by h. H. Now this h needs to reduce. And notice each term has an h, so you can cancel one h from everything. Or you can factor an h out of the top and then cancel them. So we could pull an h out. And then the h's cancel and leave the -8x minus 4h plus 9. Another way to do it, in this fraction, there's 4 terms. 1, 2, 3, 4. They all have an h. So I can divide an h out of each one. These two h's cancel and leave the negative 8x. This one of these cancel with the bottom and leave the negative 4h. And the last one, these h's cancel and leave 9. And then h divided by h is a 1 in the denominator, which you don't have to show. But if you want, you can put it there. So you know where this went. Any questions on that? The next step, we take the limit. The limit is h approaches 0. Negative 8x minus 4h plus 9. Plug in the 0. So our derivative is a negative 8x plus 9. Any questions on that? Now, if they asked us after that one, they could ask us for f prime at 2, f prime at 0, f prime at a negative 2. You wouldn't have to keep doing it. Once you do it for x, then you just plug into this value. This would be negative 8 times 2 plus 9, which is a negative 7. Plugging in 0. 0 plus 9 is 9, and so once you find that derivative, then you can just plug right into it, especially if they have more than one thing they're asking you. Find this one first, and then you can just plug in. Any questions on that? Let's try another one. There's like 3 cases. One of them was the polynomial, which we just did. And another one, oh, I don't see the fractions in this section. It's the square root. So if we have this one, now this is one when you do f of x plus h, because that would be step 1. Unlike the other one where we could FOIL the quantity, like we did here, we FOILed this. You can't simplify this one. So we put x plus h in here, but there's nothing we can do to simplify. So setting this one up all at once makes sense. I'm going to leave the limit till the end. If we do it all at once, negative 3 square root x plus h minus the original all over h. Now we have to simplify until this h cancels. Because right now, if we plug in 0, we're going to get 0 over 0. So I'm going to rewrite this part because a negative and a negative makes that a positive. Now what you want to do is multiply top and bottom by the conjugate. The conjugate is the same thing but the opposite middle sign. So we want to multiply top and bottom by this. When you have square roots, using the conjugate helps simplify things. Don't multiply the bottom out because we want that h to cancel. On the top, you only have to multiply the first two and the last two. Since it's the conjugate, the middles drop out, they cancel. So you only have to multiply the first two and the last two. Remember, when you multiply a radical times a radical, if they're exactly the same, it just cancels the radical. So -3 times -3 is a positive 9 times the square root of x plus h, and the square root of x plus h is x plus h. Multiplying the last two, 3 times a -3 is a -9. Square root of x times the square root of x is x. All over h times -3 square root of x plus h minus 3 square root of x. Any questions so far? Okay. Distribute this 9. So we have 9x plus 9h minus 9x all over h times -3 square root of x plus h minus 3 radical x. Notice on top the 9x's cancel. Once they cancel, there's only one term on the top and one on the bottom. Those h's can cancel. So this h will cancel with this one. Okay, so once we cancel those h's, this is when you can take the limit. So now we can take the limit as h approaches 0. If you plugged it in any time before that, you would have 0 over 0. So you got to go till you cancel that h. Plugging in the 0, we have 9 over -3 square root of x plus 0 minus 3 square root of x. These two are both square root of x, so we can combine them. 9 over a negative 6 square root of x, which reduces to 3 over a negative 2 square root of x. Normally you don't leave an x in a square root in the denominator, but I would not require you to simplify. You can leave the square root for these. I don't think my math lab cares either. If it does, you just multiply the square root of x on top and bottom to get rid of the radical. So then it's 3 square root of x over a negative 2x. But I would accept either answer. Any questions on that? No? Any questions? Okay. So we've covered everything from chapter 6. And we will have a group assignment on Friday. But is there any questions? Okay, if there's no questions, I will see you on Friday.